Welcome back to Solving Linear Systems of Equations by Elimination, and I hope you have just a little bit more patience to bear with me as we go over the very last example of the lesson. So I'm going to get started with the very first step, which is lining up the terms. So we want to line up the x terms together, we want to line up the y terms together and the constants together, and hooray, they're all lined up. So not much that we have to do about step number 1. Step 2, we have to make a decision which variable to eliminate. So if I wanted to eliminate the variable x, remember that we want the variables to have either exact same or opposite coefficients, so same in value, opposite in sign. That doesn't happen right away in here with x, so let's try y. So y is 7 and negative 2, so that's not possible as well. So we have to look into other options. Remember that to eliminate a variable, we need to either make the coefficient of the first term here, x, into this one, or this one into this one. So either negative 2 into 5 or 5 into negative 2. And same goes for the y terms if we decided to go for the y variable. So it is not possible, you would say, to make 5 into negative 2. Well, you can if you want to use fractions, but we don't want to involve fractions in solving a linear system when not necessary. So we're going to think maybe then we can do something else. So we can change this negative 2 into a 10 or negative 10, and this 5 into a 10 or negative 10, with 10 being the lowest common multiple of it. So if we want to do this, then that means that we have to multiply the first equation by 5 and the second equation by 2. Now remember that when you are multiplying by a coefficient, you have to multiply by that coefficient every single term in the equation. So be very focused as you go through this step, because yes, it may seem repetitive and easy to do, but it's very easy to make mistakes and leave out terms that you don't want to leave out. So we have 5 multiplying negative 2x, and then plus 5 multiplying 7y equals 5 multiplying 10 here. Second equation, we have number 2 multiplying 5x, and then we have plus 2 again multiplying negative 2y equals 2 again multiplying positive 6. By the way, you probably notice a change in your handout, so there is a plus 6 in here, not a minus as it may appear on your handout. So it's a plus 6, just in case you've missed this. Okay, now here we go. Simplify each equation, and we have negative 10x plus 35y equals 50. Next one is positive 10x minus 4y equals 12. It's easy to see that by adding the two equations now we can eliminate the x. That's what we've been working for, right? We've been working on. So we have negative 10x plus 10x plus 35y plus negative 4y equals 50 plus 12. So here we go. The x terms simplify to 0. 35 minus 4 is 31y equals 62. So y equals 62 over 31, or y equals 2. If y equals 2, what's x? Well, let's use either equation. So I'm going to use the first one, negative 2x plus 7y equals 10. Negative 2x plus 7 times 2 equals 10. Negative 2x equals 10 minus 14. And x equals positive 2. So that's negative 4 over negative 2, right? So we're going to say that the solution to this system is x equals 2 and y equals 2 as well. All right. Now, just for the fun of it, let's verify the solution by using decimals. Okay, so negative 2x plus 7y equals 10. Okay, decimals, come on. So negative 2x plus 7y equals, I think we said 10. And the second equation, just to make sure, 5x minus 2y equals 6. Okay, so let's check the intersection point in here. Let's take a look at the intersection point. It's right here. Okay, the intersection point is at 2, 2, so our solution is correct. So hooray,